Good morning, grade 5. How are you doing today? Hope you're all doing well.
Good morning,
Yes,
sir.
sir.
Yes, sir. Yes, sir.
All right.
Yes, sir.
Yes, sir.
All right. So my name is Glenroy Brown, and I'm a meteorologist at the Meteorological Service of Jamaica. And I'm here to talk to you about the functions of the Meteorological Service. I'm going to talk a little bit about the different areas. And also, we're going to touch on some of the things that you will be doing in grade 5 once it comes to weather and climate. And that include what are the elements of weather, differentiating between what is weather versus climate, and also looking at global warming and also climate change. We're also going to touch a little bit on the hurricane season, right? So because this is a presentation about weather and climate, and I want to ensure that you are a little bit interactive with me, I have a few assignments for you, right? So we are going to ask some questions during the presentation, but it's not for you to shout. So you're going to practice how to actually answer these questions, right? So during the presentation, when we ask a question, we're going to use what we call the poll method. So a little screen is going to pop up, or a little box is going to pop up on your screen, and you're just going to click the correct answer to the question and submit it, right? So you're going to get those fingers working, right? Also, to ensure that some knowledge is passed from my end to your end, I'm encouraging you to take some notes as we go along, because some of these things are what you will get on your prep exam. So I'm encouraging you to take some notes. Have your questions ready for me at the end, and we're gonna have some fun. That sound like a plan?
Yes, sir.
Yes, sir.
All right,
Yes,
so
sir.
the first thing we want to do is to establish how to use the poll question, right? So I'm gonna put a question on the screen after I share my screen with you for my presentation. Okay. Should be seeing my presentation on the screen. So let's go with the first poll question, and it's just gonna ask a simple true and false question. Right? So if you look at your screen now, um, there should be a question that is on your screen. You have two options to choose whether it's true or false. The question simply asks, I am a grade 5 student at the Portmore Missionary Preparatory School. Now, this can be true or it can be a false. So we can ask the teachers to chime into, you know, submit it and just click the submit button at the end of the poll, right? So we have a total of 29 persons in attendance. So we want to get those numbers going, right? So you're gonna interact with me today and we're gonna work together, right? And have some fun at the same time, right? So it's all about teaching and learning and having some fun at the same time, right? So let me end the poll question and I will share the results. So that is how simple we're gonna do this presentation. Once we ask questions, you're just gonna do it like that, right? So this is the poll results. That was very easy question, right? So we're gonna ask some more questions as we go along. But let's get into the real meat of the matter, why we're here and why this presentation is important at this time, right? Now, let's see if I can maximize my screen. All right, so you should be able to see my screen right now, right?
Yes, sir.
All right, excellent. So, a question that we often get asked a lot of time is, who's really a meteorologist? Is it somebody who is flying around on a broom? Is it somebody who is making using some form of method of predicting what the earth will move like, what the weather will move like? So a meteorologist in essence is really a scientist, and it's really the science behind studying the atmosphere, right? And when you look at studying the atmosphere, we only look at that area of the atmosphere that goes from the Earth's surface all the way up to about 60 miles in the air, right? Now, the thing about it with being a meteorologist is that a lot of persons confuse a meteorologist with a geologist or a physicist, a geophysicist, right? Or a geologist. A geophysicist or a geologist are someone who studies the physical structure of the Earth's surface, like the rocks, the mountains, earthquakes, volcanoes. A meteorologist don't do that. All we do is just look at the different elements in the weather, in the atmosphere, we call it, from the Earth's surface all the way up to about 60 miles in the air, right? Now, if you want to have an idea what is 60 miles, 60 miles is like from Kingston to the parish of Trelawney, right? That's like an estimate of what 60 miles will look like. So the atmosphere that we study as meteorologists comprise of basically all the air in the atmosphere from the Earth's surface up to about 60 miles, right? Now, the meteorologist is, in terms of an agency, it is a government service agency. It is actually fall under the Ministry of Housing, Urban Renewal, Environment, and Climate Change. It's also a member of the World Meteorological Organization. And what the World Meteorological Organization does, it lays down the standards for how these meteorological services should operate, right? So it tells a meteorological service like, okay, you must measure rainfall at 7 o'clock every morning, or you must measure the wind speed at 10 meters in the atmosphere, right? So that's the function of the World Meteorological Organization, and it governs the way that we do things, right?
Yes, sir.
All right, so we're just saying. So in terms of what do meteorologists do? Meteorologists are not witches, and we're not warlocks, and we don't fly around on brooms. So we are basically this this organization and this entity that looks at all the weather phenomena in the atmosphere. So whether we're looking at clouds, or we're looking at rainfall, or we're looking at wind, that is what we do, right? So as meteorologists, we have to study the atmosphere in itself. And if you look at these pictures, you'll see different areas of the atmosphere that we have to study. So if it's a hurricane over the ocean that goes from the sea up into the sky, we have to do that. If we're looking at agriculture, if we're looking at to see if rainfall, if we're looking at tornadoes and water spouts or tropical storms, clouds, the different various clouds, all of those are elements of weather. Sunshine, all of that is incorporated in what the meteorologist will do. So the meteorologist does a constant monitoring of the atmosphere to ensure that we are able to tell you when it will rain and when it will not rain, right? But who really needs the weather information? If you ask me, I would tell you everybody needs the weather information. So whether you're at school, you just want to go to school on a particular day, we know we're in the COVID-19 time, pandemic time now, and it's very difficult. So most of the time we are basically doing school online. But if you had to go to school, you need to prepare, right? So you need to know if you should walk with the umbrella today or you can just leave it. So weather information is critical to everybody, whether you're going to school or not. You could be having your birthday party and you want it to be outdoor, and you want, you know, your friends and families to be there to share in that moment with you. You want to know if it's going to rain on that particular day. That is someone just needing weather information. It could be we want to spend a nice day at the beach, but we don't want any rain. So we can have all the fun that we want. Uh, that's it. We need weather information. So we need to know if it's sunny. Your parents could be planning that perfect vacation, you know, want to go abroad, you want to go on the North Coast, enjoy yourself. But you want to ensure that while you're there, the weather don't play an important role in you not having as much fun as you should. So weather information is needed every day, every minute of the day, whether it's for general purpose or whether it's for aviation, whether it's someone who is on the ocean, but whether it plays a critical role in everyone's daily function, right? Now, in order for the Met Service to achieve this objective, we have to actually have various branches, right? So inside the Meteorological Service, there are 3 main branches. Let me repeat, inside the Meteorological Service, there are 3 main branches. They have the weather branch that deals with all weather-related activities. You have the administrative branch, which deal with all the accounting and clerical stuff, clerical service activities. And then you have the climate branch that deals with in the data collection, the data processing, and just actually preparing the type of weather information to know if our climate is changing or not, right? So that is the 3 main branches, right? Now, under the weather branch, there is a critical area that deals with the the forecasting center. And under the forecast center, you basically have all the forecasters, or what we call meteorologists. So these forecasters are what you would see. They would present on the TV. So if you watch television Jamaica and you watch the weather in the evening, these are our trained meteorologists, and they work at the National Meteorological Center, which is our forecast center. This center is actually located at the airport. But as a meteorologist, you get the opportunity not just to understand the weather, but also to be a weather presenter on television, also to be a weather presenter on radio as well. Right? So we're pretty much well involved. The weather branch, or the National Met Center, is located at the Norman Manley International Airport, right? So let me repeat, the National Met Center, which is where most of our weather activity take place, is located at the Norman Manley International Airport. Why is this located at the Norman Manley International Airport? It's one of our main international airport, and it has a lot of traffic. And what we mean by traffic, it means that there's a lot of aircraft that comes in and out of that airport. And because of that, it is required that they have a meteorological center, a forecast center located there. Why? Because we have to monitor the weather on an hourly basis. So what we do is to do what we call hourly observation. And then we have, from those hourly observations, we are able to do weather prediction. What is weather prediction? Is what we use to determine what the weather will be for tomorrow, for the next 3 days, for the next 4 days, right? So it takes all of those observations, and these observations are looking at different weather elements. And we look at the movements of these weather elements, or the changes in these weather elements, to actually determine what the forecast will be for tomorrow. So the work of a meteorologist is really not guessing, but actually understanding the science behind the atmosphere, right? The climate branch is another section that looks at reporting. It looks at what is happening in terms of weather and climate, but more so climate, right? It's climate related impact. I think somebody has their mic open. Could you just close your mic? So it looks at weather related impacts, right? Climate related impact. So what a climate branch will do is to look at the day-to-day weather and average them out over a long period of time, like probably 30 years generally. And what we'll do is to determine if these areas have a lot of rainfall, or it's just one of those areas that is constantly dry. So it looks at determining the different climate patterns for the different areas in Jamaica. And we also produce products and services that will also help different sectors. And what do I mean by sectors? It means like if the agriculture sector want to know if it's going to be a dry year this year, or can we plant some sorrels so we can get that for Christmas? What do you think is going to happen? They are kind of guided by our predictions and our information based on study of the weather over a long period of time, right? So the climate branch deals with all the climate related products and services. All right, so I have a quick questions for you. So let me just slide out of this and give you the poll question. So the question So remember how to answer your question, right? All right, so this question I'm going to pose on the screen, so you should see it shortly. And the question asks, do you think that climate and weather are the same thing? So click and submit your button if you think they are the same. If you think they are not the same, so click and submit, and then we discuss. Right? Excellent. So we have like about 32 answers coming in. Yeah, and we have like about 39 persons in the. So I can end it here, and I can show you the result. 94% of you think that they are not the same thing, and you're actually correct, right? So let me stop the sharing and in this. All right, so you're absolutely correct, right? They're not the same. And why they're not the same? Because of this important definition, and we need to distinguish them. So weather is the state of the atmosphere at a specific time and place. What this means is simply mean whatever is happening outside, that is the weather. So if outside is sunny, that is the weather. If outside is rainy, that is the weather. If outside is dry, that is the weather. If outside just feel cool, that is the weather. If you feel windy, that is the weather, right? So anything that is happening right now, current place and time, that is weather. However, if we are supposed to monitor the weather on a daily basis and look at it as an average over a long period of time, like 30 years, then the average weather over a long period of time is then referred to as climate. So first we need to have weather before we can determine what the climate will be. So remember, weather come first, climate come afterwards, right? And there are two other definitions that we want to expand on. It's just because these are sometimes definitions that will come on your PEP questions. And global warming is one of them, right? So global warming is just a gradual increase in the overall temperature of the Earth's atmosphere. What does this mean? It means that if we measure the global temperature from year to year, and if there is a constant increase in the temperature from one year to the next, then it can be considered to be global warming once the change is significant. And to be honest, that is what we have been experiencing for the past 16 years. Every year is hotter than the year before, are just as hot as the year before. So what has happened is that we have been setting records on top of records on top of records. And this summer won't be any different. It was just going to be go down at one of those hot years again. Climate change is another definition that we just want to bring out there. And it is the long-term change in the average weather pattern, right? Now, what we mean by the average weather pattern, remember we have to average up all of the weather patterns to get our climate. So just imagine if 10 years ago, when I averaged the last 30 years prior to that, my average temperature was 15 degrees Celsius. But this year, when I measure it, which is 10 years onward, my average temperature now is 17. So it means that I would have increased by 2. So the climate change, it means that my average temperature is no longer 15 and it is now 17. And it's because of these changes in temperature why scientists refer to these long-term change average as climate change. Right? Now, for years, we have been seeing the signs and the signals as to what is changing with our climate and what is changing with our weather. And some artists, some scientists, some researchers have discovered what these changes are. And even in Jamaica, one of our artists had asked a question once, what if tomorrow morning you wake up and Jamaica just start to snow? What do you think that would mean, right? And let me just play a clip from it. I know most of you might not know Busy Signal, but Busy Signal is a local Jamaican artist. Maybe a couple of years ago, he released this song. So I just want to play a short clip for you. So just listen to the song. If you know Busy Signal, then you might have known the song, right? But if you don't, Don't worry. This is just listen.
Yo, one time we sit down and pray. Sometimes I wonder if, what if tomorrow morning Jamaica starts to snow? What if that's how the story go? Yeah, you never know. Gotta come. Fast as you wink, dirty heart and wicked I go sink. You never know. What if your best friend turn you for? What if tomorrow morning Jamaica start to snow? What if that's how the story go? Yeah, you never know.
All right, so back then, Busy Signal did a very controversial song, What If, right? Now, the idea is that we know that God is the ultimate creator of the universe, and he created a perfect atmosphere, right? However, with time, our atmosphere has been changing because of things that man-made things that the human actually introduced to the atmosphere. And it's because of these changes, then you realize that climate are changing around the world. Not to say that Jamaica will actually have snow, but it's to say that our climate will move from one extreme to another, right? And this is what is actually happening with the climate. So let me actually use this scenario of actually describing what is happening to the climate by using a cup of tea and to actually look at how the atmosphere and the cup of tea are so similar, right? Now, if you are supposed to make a cup of tea, there are certain things that you need to put in it. There are certain ingredients. You need a tea bag, that's for sure. You need some water, and you need some sugar, right? Now, just imagine if I decided that, okay, on this given day, I'm going to put one tea bag, I'm going to put 1 teaspoon of water, and probably half cup of sugar. Obviously, the tea is going to taste different, right? And if I continue to drink that type of tea, after a while, I'm going to start develop symptoms. If I might have a tooth decay, or I might have diabetes or something, but after a while, the symptoms will start to show in your body. It's the same way the atmosphere is designed. The atmosphere ingredients are the various gases in the atmosphere, like nitrogen, oxygen, water vapor, carbon dioxide. But carbon dioxide is that one that makes the atmosphere gets warmer. And how do we get carbon dioxide in the atmosphere? One of the things that increase carbon dioxide is that if you cut down the trees, because trees remove carbon dioxide from the atmosphere, and persons are cutting down trees. So when you cut down the trees, it actually increase the amount of carbon dioxide in the atmosphere, because there's not enough trees to remove the carbon dioxide. The demand for electricity is one of the biggest culprit of carbon dioxide in the atmosphere. So what this means is that the industry are actually burning fossil fuel, which is gas, to actually produce the electricity. But the gas in itself, just to burn it, let go the carbon dioxide, the fumes into the atmosphere, which increase it, increase the amount of carbon dioxide that is in the atmosphere, right? And it's this increase in carbon dioxide that is actually causing the Earth atmosphere to get hotter and hotter. So what are the symptoms? Yeah, we know maybe what are the symptoms if we drink too much sugar in our tea, but what are the symptoms for actually having too much carbon dioxide in the atmosphere? Some of these symptoms are we're getting hotter temperatures. We are currently seeing that, right? Some of it will be rising sea level. We're actually seeing that. Some of our beaches are being eroded. So if you go places like Elsha, where you used to walk or far out in the sea, or if you go Port Henderson, the beach is actually, the land is right there on the beach now. And another symptoms of having too much carbon dioxide in the atmosphere is actually extreme weather. When we have storms or when we have weather events, they are very powerful. There are a lot of flooding, and they are very powerful storms that sometimes develop. So these are some of the symptoms or side effects, as what I would call it, if we continue to increase the amount of carbon dioxide in the atmosphere. So we as humans, we know that God created a perfect atmosphere, but with change from human activities, this is what is happening to our atmosphere, right? And our ends global warming, right? So I'm going to take a couple minutes to look at some of the things that we call weather elements and their parameters. Now, weather elements and parameters are very important to meteorology because this is the only way we can determine what is changing and what is there, right? So you might know some of these elements already. Rainfall is one. We measure rainfall in millimeters, and we soon get to the instrument. With atmospheric pressure, we measure that in millibars. Temperatures, we measure it in Celsius. Some areas use Fahrenheit, but the international standard is Celsius. Humidity, it's measured in percentage, so it's normally a percentage of how much moisture is in the air compared to how much it can actually hold, right? Wind speed and direction, these are wind speed is in knots, direction is in degrees, and sunshine is in hours, right? And cloud cover would deal with that in octaves. So we divide the sky into 8 equal parts and then call them octaves, right? So remember, sunshine is measured in hours, so we determine how many hours of sunshine we have during the day, right? Evaporation is measured in millimeters, and we get into the instrument. But in essence, these are our elements of weather. And these are the elements of weather that, as a meteorologist, we have to monitor. And when they are changing, then we have to say that they are changing in the atmosphere. And one of the elements of weather that is constantly changing is temperature. And this is a warning, a very worrying sign for scientists like myself, because if the temperatures continue to change, it's going to have a significant impact on our climate and our condition and how we have to adapt. The talk now is that outside is going to get so hot that you can't even work outside anymore. And then, we have a lot of persons, laborers and stuff that still have to work outside, right? All right, so let's get into some of the instruments that coincide with these elements. So in order for us to measure an element of weather, we must have an instrument to capture that information. In meteorology, the instrument that is used to capture the amount of rainfall is called a rain gauge, right? There are different types of rain gauge, but this one that you're looking at is a typical type of rain gauge with a bucket. But we're trying to phase out these rain gauge and come in with the rainfall, we call them rainfall logger intensity, rainfall intensity logger. Now these rainfall intensity logger, they measure the rainfall just the same, but the only difference with them is that there's two differences. One, it can be placed out into a remote area, meaning that somewhere where you don't have anybody to actually measure it, right? The first one, we have to have somebody to measure. Two, it is actually using a technology, a tipping bucket technology, which can actually measure the intensity. What do I mean by the intensity? It means that how fast the rain is falling. So if we have in like 20 millimeters of rainfall in 1 hour, it can tell you that. The actual manual gauge that we looked at before is not able to tell you that. So we're able to use these rainfall loggers to tell how intense the rainfall is, right? And this is critical, especially in reporting, right? Atmospheric pressure, we still use our barometers to measure that. A lot of the mercury barometer, however, have been phased out. So this Q pattern mercury barometer is one of the old time ones. We no longer use those because mercury is kind of a poisonous substance. So we actually using more of what we call the aneroid type of barometer. And the difference between the mercury and the aneroid barometers is just because the mercury use mercury, yes, but the aneroid barometer is just some metal chambers that expand and contract based on the pressure, atmospheric pressure forcing down on the chamber itself. So as you could just say, one is with mercury and one is without mercury. But this is where the technology is going. We are phasing out the mercury barometers and we're now using the aneroid barometers, right? Thermometer is the same thing. Most of the mercury thermometers we're phasing out, and thermometers is the instrument used to measure temperatures, right? But we're phasing out most of the mercury type ones, so newer technology, right? And most persons would have an idea what a thermometer is because when you're not feeling well and mommy want to take your temperature, it's the same thermometer she will stuck on their arm and measure your temperature to see if you have a fever. But the only difference is that we expose this one to the air outside, while mommy would just want to know what is your body temperature. Right? That's the only difference. All right, so we have for measuring humidity, we have our aspirated hygrometer. This is the new type of instrument that used to measure humidity. It basically used two thermometers to do the same function. However, back in the days when we were just studying humidity, we used to use more archaic technology, which meaning that we used to use things that, a matter of fact, they were using the human hair because it contracts and expands based on heat. And the girls will know this, and the female teachers will know. Basically, your hair responds to heat very well. So, for instance, if you wash your hair, it tends to shrink and get shorter. While if you blow dry it, it tends to get longer, right? So it responds very rapidly to heat. And this is what they used to use back in the early days to measure the amount of humidity or amount of moisture in the atmosphere. So when the instrument, when there's a very little moisture in the atmosphere, the air would stretch very, very far. And then when the atmosphere is very moist, it then would contract, right? So that was the first time technology, but we have upgraded that technology now to aspirated. And I think even some of the aspirated now will just use a fan basically, and it just spins below the instrument. Capture it. Our wind speed, we use our anemometer to measure our wind speed. These anemometers can be in different form. Most of the most popular one though is a cup counter anemometer, which basically just the wind will get inside the cups, 3 cups, and they just spin around and you measure the actual speed. This is a handheld anemometer, but they are more powerful and larger instrument that we normally place out into the field. This is one of the ones that we place out in the field, but it also has not just the anemometer attached to it, but also the wind vane, right? So the wind vane is what we use to tell the wind direction. So you can use a wind sock or a wind vane. Any one of those will capture the direction perfectly. Sunshine, for our instrument, we use our camber stroke sunshine recorder. As technology changed, this can't change. It has never changed. And this is not a crystal ball. It is actually a large magnifying glass that is used to actually burn the paper from one end to the other. And it gives the gradation in hours. So we'll know exactly how many hours of sunshine you have during the day. So the magnifying glass, if you know what a magnifying glass does, it's really a verb. It magnifies the intensity of the sun rays to the point where it can actually burn. So that is what is the same technology we're using from day one. That has not changed. We have used other technology to measure the intensity of the sun and the energy that is coming from the sun. But this is the only instrument that we can use to measure the duration of sunlight hours, right? And it's called a camber stroke sunshine recorder. A lot of our observations and monitoring have to do with visual observation. What do I mean by this? It just look at, oh, what are we seeing in the atmosphere? Is it that this is a cumulus type of cloud? Is this a stratus type of cloud? Is this cloud at 2,000 feet? As much as technology is good, a visual observation, nothing beats a visual observation. And we still have to do these visual observation every hour on the hour, especially at the airport because we have a lot of aircraft coming in and leaving, right? So we still do these observations to know the cloud amount, the type of cloud, and the height of the cloud. We can use an instrument known as a ceilometer to actually measure the cloud base. That is how high the cloud is from off the ground, right? But it still can't tell you the type and the amount. So we still have to rely on that visual observation. Actually going on top of the roof, doing an observation, looking in all different directions, and looking at the different types of clouds, right? These observations are done every hour at all meteorological services across the world. Our evaporation pan is something that we use to measure the rate of evaporation. What does this mean? It just means that how fast is water leaving the Earth's surface. It's a very old technology, but it still works. There are other technology that are being used now, but this is still being used at most meteorological organizations. Technology is changing, definitely, and we have to move with the technology. I remember when I just joined the meteorological service, we had like probably about 500 manual rainfall gauges right across the island. Now that number has reduced to probably less than 200. And a lot of those numbers have been replaced by what we call automatic weather station. And the automatic weather station is just a compact system with all the different instruments for measuring all the different elements of weather. So they will have like on it, you will have the rain gauge, the thermometer, the anemometer, and so on and so on. And it's just one compact thing. It's using technology like the internet, or sometimes it uses GSM technology, which is basically phone technology to actually transmit the information from the location back to the office. The good thing about this is that you can sit in the office and remotely know what is happening at any location across the island from one of these stations without actually physically going to look at the station, right? So that's a good thing about it. So we're moving in that direction to increase our number of weather stations, so automatic weather stations, right? I know we've been talking about weather and elements and so on, but all the elements and weather that we're talking about from these instruments are actually the weather elements that are measured on the ground. But when you study meteorology, meteorology is not about elements on the ground. It is about the atmosphere, and the atmosphere we say is about 60 miles long, right? So we have to know what is happening up in the atmosphere. And one way to do that is to use an instrument known as either a weather balloon or a radio sound. And basically, it's a very small electronic device connected to a balloon that is inflated with hydrogen gas, which is very light. And then we'll release this into the atmosphere, and it will measure the different elements of weather, measure the temperature, the pressure, wind speed, direction, you name it, going up into the atmosphere. These balloons can travel very far sometimes, and it goes even way up into the upper atmosphere, and astronauts even use this type of data at times. Right? We also use our Doppler radar system, which basically gives an idea as to how much rainfall and the intensity of the rainfall, and which areas are having the rainfall. So it's a critical tool. We're currently installing a new radar system, and that will be in operation soon, because the last one that we had I think was about 20 years old. One of the main responsibility of the meteorological service is to monitor hurricanes. So during the hurricane season, which runs from June 1st to November 30th, is one of our busy seasons. And this is a time when we actually do a lot of observation. This is a time where we actually have to be monitoring if this tropical wave is going to intensify into a tropical storm. We have to send out warning system to evacuate our fisher folks and persons who are living in vulnerable areas where a hurricane might pose a risk. We have to be on the high alert. So during the hurricane season, the Met Service is on high alert. And we normally advise our residents to be on high alert as well, to pay attention to releases coming out from the meteorological service. But this is a critical function of us, right? So it doesn't matter which stage the system is, whether it's a tropical depression, a tropical storm, or hurricane, which is the monster one, they all can pose significant risk. So being on high alert is just what you have to do. So during the hurricane season, which run again from June 1st to November 30th, we have to be on high alert, right? These systems are not small systems, they are monsters. Look at this one. This is Hurricane Dean. This is in 2007. And if you look at the size of Jamaica compared to this hurricane, you can see how huge this system can be. So one of these systems can just engulf the whole island and just cause major damage. So that's why we have to prepare ourselves, right? And to actually ensure that we are safe. The damage from these systems can be tremendous. Look at this. This is Caribbean Terrace. This was in 2007 when Hurricane Dean struck, and it totally destroyed houses that were close to the coastline here. Now, these are houses that person used to live in, right? But they are totally destroyed because of the storm surge and the water that comes in and the wind. It totally destroyed the building, right? So that's why we have to be on high alert during the hurricane season. All right, so question time again, right? So Get those fingers ready. Get those fingers ready. About to put another poll question out there. So get those fingers ready. Let me put my poll question up, and you will tell me what is the answer. All right, so my question should be on your screen. So the question asks, do we have tornadoes in Jamaica? Is this a yes or no answer? Yes, man. I said the question. The answer is coming in. So get those fingers working. Get those fingers working. We see them coming. Excellent. 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 Yeah. Yep. So give me a few more seconds. Yep. 31. Anyone gonna make it 32? All right. 32. All right. Let's end the poll here. 33. Okay. All right. Let me 34. Wow. All right. Excellent. Oh, we're still going. 35. All right, so let me end it here. 35 is good. Let me share the results and let me discuss it, right? So 66% of you says that no, we don't. 34% of you says yes. So let's discuss this. Let me get back to my presentation. So 66% said no, right? But the correct answer is actually yes. And let me explain. Tornadoes are very powerful wind type systems that comes from what we call cumulonimbus clouds or thunderstorm clouds, right? So whenever you hear a thunder outside, the thunder don't necessarily produce just thunder and lightning, right? The cloud don't necessarily produce thunder and lightning. It can also produce what we call tornadoes. Now, there's a difference between what's a tornado, a funnel cloud, and a water spout, and what some people classify as freak storm, and what some people classify as twisters, right? So let me just break them down in its entirety. Now, in meteorology, a tornado is this powerful wind system that comes from cumulonimbus cloud or thunderstorm cloud. If it touched the ground, if so, it coming from the cloud, you know, so remember, not coming from the ground, it's coming from the cloud. So if you hear the thunder outside and then you see that the wind start to spin outside of the cloud, it will come all the way down to the ground and touch the ground, it is then considered a tornado, right? However, if it comes and touch the ocean, in meteorology, we call those water spouts, right? But it's the same thing. And if it sometimes it's spin all the way down, you know, but it don't touch the ocean and it don't touch the land, then it is then considered to be a funnel cloud. Now, why some people would say, no, we don't have them here, is because of the media concept of it, right? So in America, the media concept of a tornado is oftentimes called a twister, but it's the same tornado, right? But they call it twisters because those are big and powerful. Yes, they're more big and powerful in the United States. In Jamaica, our media tend to call them freak storm. So these freak storms tend to just come, and the fisherman will say, boy, I see it come off of the sea, you know, and then it just come over upon the land and it tear down the building and the trees. Tornadoes. And these tornadoes, they're not as powerful as the one that are in the United States, but they are just as damaging to infrastructure, buildings, trees, etc. in Jamaica, right? So the correct answer to this is that yes. So the 34% of you that says yes is correct, right? So we do have them. Now, to differentiate it between what comes from the ground, because sometimes persons say, oh, I see a tornado on the ground. Tornadoes come from the sky. They don't come from the ground. So the ones that you see on the ground are generally what we call twisters or whirlwind, right? Whirlwind are dust devils. So, you know, they just spin up the little leaves and the trash and the dirt. And you see it spinning, going up into the sky, right? So those are like the whirlwind or the dust devils. But the actual tornadoes, they come from the cloud, from the sky. So you actually see the cloud coming down at you, right? And they're very dangerous and very powerful, right? So that's the distinction, right? So let's move on. All right, so that's my presentation in a nutshell. So I'm gonna pause this here and then gonna leave it for question and answer. We're gonna use the raise hand feature for question and answer. I have some more questions to ask you, but after your question and answer with myself, right? So, right. So that was my presentation in a nutshell. I hope you learned something from it. So we see people using the raise hand feature. So I think this is Roger. I go with you first.
Okay, Stacey. I want to ask, when is it going to rain again?
That's a trick question. Um, we have been monitoring the weather pattern for many years and many months. And to be honest with you, May is not normally one of our dry months. It is what is considered to be our secondary rainy period. When I was growing up, we used to go pick mango and I pick mango in the rain. Them things are kind of the climate. Remember, so climate has changed. That is exactly what is happening right now. So right now we are in May, and it's so hot. We don't even, and Portmore, Portmore hotter. We don't know when the next rain. But as it is right now, if you look at the forecast, the next 3 days looks like it's gonna be hot in the morning. There's a chance of some showers in the afternoon, but it's mainly over the hills. So places like the plains and stuff, not gonna get it. So we don't see a real rainmaker in the forecast yet, but definitely just keep monitoring the weather, and we will definitely inform you about it. All right,
Okay, fine.
Courtney, that's your time.
My question is that, like at the meteorologist place, do they assign certain people to do certain things to see how much sunshine, what is the speed of the wind and everything?
Excellent question. Yeah, we do. So, all right. So for instance, we have different persons who will specialize in different things. For instance, I'm a specialist in what we call seasonal forecasting. What that just mean in a nutshell is that I can predict forecasts up to 3 months, 6 months in advance, right? So I can tell you if it's going to be a drought 6 months in advance. And I work closely with different sectors like agriculture, water sector. But those sectors need to know if it's going to rain so we can plant certain things, or is it going to would we have enough water in the reservoir so we don't have to have water lock off? That is my prediction. That is how that's what I specialize in. At the airport, you have different persons who specialize in different things. For instance, you have the observer who will be monitoring the sunshine hours. He will be measuring the temperature every hour. He will be measuring the rainfall every 6 hours. So at the airport, you have constant monitoring and supervision. And those persons are called our weather observer. And then you have the next tier of workers, which is called our weather forecasters, and the weather forecasters are meteorologists, and what they will do is to take that information that the observer would measure and then put it on a more complex system, and then we're able to predict based on movements of the atmosphere what the weather would be in the next 3 days, 5 days, 6 days, or so on, right? So we're able to do that in advance, right? So, but there are different persons who are assigned for different roles. So at the Met Service at the airport, you have observers, you have forecasters. At the climate branch now, like myself, I'm assigned to do these type of presentation and also to go out into the field and talk to farmers, to know what farmers really want, what are they expecting from us, how can we improve the service that we provide to them, right? And so on, right? I think, I'm not sure who is first. I think this is Sasha. Edwards, go ahead.
Do you enjoy being a meteorologist?
That's a question I get asked a lot. And I must say, I've been doing this for a while and I really love it. Not just to come and talk to you, but there is the opportunity that you get to do things, right? Now, I can tell you that my job as a meteorologist have taken me all over the world. So if you go and look for me on Glenroy Brown on Google, you'll see me all over the world, whether I'm in Finland, whether I'm in Germany, whether I'm in the White House in Washington, just talking to persons about the type of weather and how meteorology help persons in Jamaica. We actually, And one of the things too is to work with different sectors and different agencies and different type of people. Because I work with farmers, not just in Jamaica, but all over the world. I work with farmers all the way up in the Blue Mountain. So just imagine, just drive to the Blue Mountain, and I'm not so, I don't like heights that well enough. So even just going up to the Blue Mountain, it made me get nervous because it's so high and it's a lot of steep hills. But I travel all over the world and to a lot of different places. And it's exciting to work with different people, to know exactly the type of service that we are providing to them and how they use the service. So yes, as a meteorologist, it gives you the opportunity to know people across the world, to actually showcase your services, and it's a great thing, and I love it. All right, so I think this is Catherine.
Yes, sir. My question is, if a hurricane happened in December,
Mhm.
will the hurricane season months affect it? Like it has to be different, the month?
That's a very good question. So what they normally, they still classified it as a hurricane, but it's still considered, it would be outside of the hurricane season. So I think it is still considered to be within the same year. But if it was a hurricane that started in January rather than December, it would have been classified as a hurricane in that year, right? So it is still considered a hurricane in the year that it formed in December, but just outside of the hurricane season. And we're seeing that more and more, because even right now, we're monitoring a system just north of Bermuda, but the hurricane season don't start until 11 days time from now, right? So, but this system looked like it might form before the hurricane season. So this is what we're talking about. It is because of these man-made changes to the environment, that our climate is changing, and we're seeing more and more of these shifts. So it's no longer that systems now are conformed to that time period. They can form outside of it. And we're seeing that so often. Almost every year we have that happening. Either a system formed early or one that formed late. Yeah, yeah, but it's still considered within the same year. Right? Let me go with, I think this is Michaela. If I pronounce your name incorrectly, please, Thompson. Okay.
Question is, will the weather change unexpectedly at times?
That is so true. That is why it changed unexpectedly, but not surprisingly. So unexpectedly meaning that it's sudden, but it's not surprising because why? As meteorologists, we monitor the weather constantly. It's not like you guys who have to go about your daily business, and it's not until you realize that, oh, it looks like it's going to rain now, then you realize that the weather changed. With us, we're constantly monitoring. So if we realize, say, at 5 a.m. this morning, we said that the forecast would be sunny, and by 7, it started to get cloudy, right? We will then adjust the forecast accordingly, because we're constantly monitoring every hour. But for you guys, it just looked like a sudden change. So that's why sometimes meteorologists get a bad name, you know. Sometimes people don't like weatherman because they don't know what I'm talking about. But the technology has changed, and we are not so far behind anymore. So it's not like one time where we have to wait 6 hours in order for us to get information. No, with the advent of internet, we have that technology right at our fingertip. So we actually have information constantly. So we can monitor the weather constantly. All right. So as this change come along, we can monitor. This look like Joel. I think that's Joel.
Sir, why do we have designated months for hurricanes?
Why do we have dedicated one?
Why do we have designated months for hurricanes?
Oh, excellent question. All right. That's a very good question, right? All right. So for a hurricane to form, right, one of the first criteria is that it needs, the ocean that itself needs a temperature of at least 26.5 degrees Celsius. So let me repeat. In order for a hurricane to form, the ocean needs to be at a temperature of about 26.5 degrees Celsius. what time of the year that this normally happen? During the summer months. So that is why the hurricane season runs from June to November. Outside of that, the ocean start to get cooler, so those temperatures are not there. So it's very difficult for hurricanes to form. Sometimes it will, but it's very difficult, right? And if they do form, they don't last for very long. So this is the reason why we have this dedicated period during the time of the year when you have the highest temperatures, right? And that period runs from about June to November. And this, the last name is Robinson. So could you go ahead? Jabari.
So this is my question. Can a hurricane start when it's not hurricane season?
Yes, it can. And it's the same thing we just said a while ago. There's a system right now. It's not a hurricane yet. It's not a tropical storm yet. It's not a depression. Don't have a name yet, but it's very active. And the scientist says that it has 70% chance of forming in the next 5 days. So this is a perfect case of a hurricane forming outside of the hurricane season. If it do form, it will form in May, and the hurricane season runs from June to November. So yes, it can. And we have seen those time and time again, right? All right, so let me go to the next person. This is like Sasha Edwards.
Sir, what if it actually snows in Jamaica? Will Jamaica be prepared?
No, we wouldn't at all, I tell you. It would mean our climate would have changed so significant that our temperatures would have moved from what is typically considered to be tropical temperatures, warm temperatures, to cool temperatures. It can, however, form ice, or what we call hail or hard ice. You can have those because we do have them from time to time, especially in the mountainous areas. You tend to have either like a tree limb or windows just frozen because of the block of ice that are on it, but not to the point where we get soft ice, which is what we call snow. Our temperature would need to change significantly, meaning that we would have to have, it's like when you're in the USA and they have like these very low temperatures, cold temperature, and everybody have to have on jackets and stuff. We'd have to get to that point. But we live in tropics, and I don't think we'll get to that point. But we'll get to a point where we start to have more severe storms and more of these hailstorms, right? But not to the point where it gets snow. That's just my prediction. I'm hoping, and then because of climate change indicate that our temperatures will be getting hotter, not cooler. So if climate change was predicting that our temperatures will get cooler, then yes, but it's the opposite. All right, Nathan, your turn.
Sir,
Yes.
why does a tornado, if a tornado is supposed to happen in Jamaica, usually it would happen for a short period of time, but in other countries, most likely, a tornado would last over 2 minutes?
Yeah, it's the same short period. So they're very swift, powerful system, and they don't last for very long, to be honest. A couple of minutes, and they just destroy and move on, right? So in larger areas like the United States, what you tend to have happening is like several tornadoes behind each other. It's like how you'd have like a line of traffic, a line of cars moving. That's how the tornadoes will go. So you'd have like several, one dying out and the next one forming right behind it, and they're all moving in the same direction. So with us, we might just have just one. So we don't have that many tornadoes touching down. But those systems can get very powerful in the United States. So you have several of them, right? But the time period, as you asked, are generally a few minutes. And that is why whenever the United States issue warnings for tornadoes, you have to take the heat because you have very little time to prepare yourself. So they can just touch down anytime, right? Very little time, right? Let me go to Roger.
Sir, I have two questions.
Sure.
Has it ever snowed in Jamaica?
All right. So let me answer that question. The answer to that question is no. But we have experienced severe hailstorm, and we have experienced severe icing. What do I mean by this? Is that we have very hard blocks of ice. Hills can be like marble size. You ever play with marbles? You know what are
Yes,
marbles?
sir.
Yeah, right. So they can be
Yes,
like
sir.
marble size and they just drop in from the sky, right? So if you are in the country areas, they tend to experience them more there, but we wouldn't get snow. And then the ice would be like if you get way up into like the Newcastle, Blue Mountain areas, you tend to see that the ice forming on the trees and the leaves and so on, right? But not the snow, right?
So the other question
Yes,
is,
go ahead.
a meteorologist can't tell the weather with the devices. What can it tell when an earthquake is going to happen?
No, and that is one of the things I was trying to differentiate when I just started the presentation. There's a difference between a meteorologist and a geologist or a geophysicist, right? So a geologist studies the physical. What I mean by physical, something where you can touch. They study the rocks, the earth surface, the soil, the moisture, whatever.
Mr.
While
Brown, we're not hearing you there.
you're not hearing me? Okay.
Yes, sir, we're hearing you.
Yeah, the other students are hearing it.
I'm hearing fine, sir.
I'm hearing as well.
Okay, right.
See.
So Campbell? Yes. Could you check your system, Mr. Campbell? Because the students are hearing. All right. Hello?
Yes, sir, I'm hearing.
Okay, okay. Right. So we wouldn't have that. So as a meteorologist now looks at just the atmosphere and the elements within the atmosphere. And the atmosphere is between, say, surface and about 60 miles up in the atmosphere. And all we look at is elements. So we look at wind, pressure, temperature, right? And if those change, what will happen to the weather? Would it be cloudy? Would it be snowy? Would it be sunshine? While a geologist looks at the rocks, rivers, and those physical features on the Earth's surface. And a geophysicist now looks at earthquakes and volcanoes, right? So there's two different sciences. So what they will do is look at these physical movements of these structures on the Earth, like a shift in the plates and stuff, and then they will determine what is happening. And that science is so difficult that it's not easy. I can tell you, it's not easy to predict when those shifts are likely. But there are certain time of the year that they are more frequent than some, right? And they have studied that and know that. But it is more difficult to predict that than it is to predict the weather, right? Even although the weather will change rapidly, right? All right, so we have Rolando.
All right, sir. My question is, what causes water sports and why and when do they form?
All right, so remember we're saying that water spout is the same thing as a tornado. The only difference is that the water spout, it goes onto the ocean, while the tornado go onto the land, right? So that's the only difference, right? So what caused it in the first place? There's a cloud. What caused it in the first place? There is a special cloud known as a cumulonimbus cloud, right? You don't have to remember the name. Just remember that it's the only cloud that produces thunder and lightning. Only cloud that can produce thunder and lightning. So whenever that cloud is out there, what tends to happen is that that cloud goes from, it can go from 2,000 feet to well over 20,000 feet in the sky, right? Now, when it goes that high up into the atmosphere, it tends to have a lot of moving parts. What do I mean by this? You tend to have either a lot of ice particles that are forming and falling, and you tend to have a lot of wind within the cloud itself. So because of those forces that are produced, because of the movements of ice, water, wind, the clouds get so powerful sometimes that they start to have strong winds coming out of those clouds. If those strong winds come down and touch the ocean, it is then called a funnel cloud. But if the same strong winds come down and touch the land, it is then called a tornado, right? So there is the same family of events, nothing different. It's the same family of events. and nothing is different, right? The only thing is one is on the ocean while one is on the land, right? And if it's not on the ocean or not on the land, they will call it a funnel cloud, right? All right, so Chloe,
Mr. Brown, just before you go,
sure,
I have experienced this water sports. My family house is on the Kingston Harbor.
yes,
And actually, we saw it forming in the Kingston Harbor.
right,
And
yes,
actually, it traveled from the water
oh, yes,
and it hit our house and every house that was behind us. All right,
oh,
but it came with a lot of moisture, but mostly
yeah,
wind.
wind, yes,
And I mean, it actually shattered the front door. And what we failed to do was to open the back door to let it out. We trapped
oh,
it. So it shattered the front, the back door. So
right,
what you said that if it's on land, it's tornado. If
yes,
it's
oh,
on the
oh,
water, it's a water spout.
oh,
But
right.
when you are a hermaphrodite spout,
Yeah.
what do you call it?
No, it just transformed from one to the other. It just reclassify it. So it's the same thing like if a hurricane moved from over the ocean to over the land. It just reclassify it, and that is how we move with it. But in the science of things, it's the same class of event, and it is always good to come and do a presentation like this and talk about the science that we know. But to hear it real life from someone who actually experienced it, it's really phenomenal. And I'm glad that you shared this with us because students, that's a question that was asked, and 66% got it wrong, right? So we must prepare ourselves. And if you heard what the teacher said, she said that okay, maybe if she had opened the back door, some of that wind would have gone out, right? It's so true because it needs an avenue to be let out from, and it comes so sudden, and sometimes you're just unprepared. And with the winds, it catch you off guard, and it's gonna lick down your flower pot, everything that is there, right? So just remember, this is an event that happened here. It just might not be as powerful as the one in the United States. Here we do call them freak storms. Sorry, we call them the freak storms because the media don't want to have this distinction to say whether it's a funnel cloud or whether it's a water spout or whether it's a tornado. In the United States, they call them twisters because they are such big monsters themselves. So it's really nice of you to share that with us. And I'm hoping your students would have heard what you have said and take heed from that. So yes, going forward, we do have tornadoes here, right? Just might
One
be
last question, Mr. Brown.
Sure.
How closely the Met Office work with NWC during the hurricane season or even prior to? Because what I've noticed, especially with the catchment on Gardentown Road, a lot of water is being wasted because the Mona Dam is full with silt and sand.
Oh, yeah.
You know, and so is it when you do predict, let's say I don't know, 7 inches of rain or 12 inches of rain, you said, all right, people, NWC get to know act together because this is coming. How closely you work with?
That's a very good question. And that fall under my portfolio as well. And to be honest, that's one of the things that we're working with them very closely now. They're a part of what we call our disaster management plan. And once I am predicting whether it's gonna have less rainfall or more rainfall, they are informed. They are part of the plan, the meeting, and they make management decision based on what they see fit. There are some things that they can do in the short term, while there are some things like the silt in the dam is a long-term thing which they really need to invest in. But there's no other reservoir in order to drain that to actually have that work done. But what we have done, what we have really loved what they're doing now is that during the dry season, they are very proactive because we are giving them this type of information 3 months in advance to say, listen, the upcoming season looks very dry. So start to have some water management plan in place, and they're actually listening to us. So if you notice, probably over the last 2 years, they have been putting some plans in place. and they have been using that to their advantage. And I think it worked effectively this year. So they were actually much prepared this year compared to last year, right? Yeah, but that is what we're doing. We're working very closely with them, not just from my department only, but also from the weather department, which will actually provide weather information for them when we're having heavy rainfall events.
Thank you.
Welcome. All right, so we have two hands that are up. Jamoy, if I pronounce that, McNeil. So if you could just go ahead, please.
Sir, is it possible for rain to fall like at the back of a house but not at the front?
Yeah. That's a question that let me tell you this straight up. The answer is yes, right? And let me tell you why. I don't know if I'm gonna explain it as best as possible, but let me explain. There are some clouds in the sky which we call cumulus clouds. Right? You might heard the name before. These clouds are what we call they're detached, meaning that them separate from each other. So even if you see them in other cloud, them look like cauliflower, or they look puffy and white, but they're detached. So what could happen is that one of those clouds could be more to the front side of the house, and then on the other side, you don't have it there. And then the rain is falling from the one that is on the, say, right side of the house, but the one that is on the left side is not having it. But if you actually look at those clouds, they're actually detached, meaning that they're separate from each other. So they don't behave the same way all the time. What do I mean by this? Is not that if one cloud start rain, all of them start rain. They're detached, they're separate. So they think a lot differently and they reach their saturation point differently. So you could have this one on the right that is actually raining and the other one that is not. And we have seen that so often, especially if you're traveling on the road, because these clouds are so detached, you'll be traveling on the road and you're under the cloud, the cumulus cloud that is giving you the rain, right? And then just a few feet down, the rain just stops suddenly, so boom. And then this side is dry, and then where you're just coming from is wet. So yes, and that type of event come from that type of cloud that is called a cumulus cloud. So with stratus cloud now, they will cover the entire sky. So and they think and they're in uniform. So if it raining in one section, it rain everywhere. But the cumulus clouds, remember, they are detached, so they're separate. So one can be having rain and the other one not having any rain. Right? All right, let me. I think.
Thank you, sir.
You're welcome. Roger, your hand is up.
Okay, so this is my last two questions.
All right.
So isn't a vortex, isn't a water sports like a vortex in the water?
Excellent. You're studying beyond me, man. So yeah, a vortex is anything that is of a velocity and a rotating speed. And yes, a water spout in the water or even the tornado on the land is a vortex. And it's something that we study significantly in meteorology. These vortex though, we do call them cyclones rather than the word vortex. So you might hear the word cyclone more than you hear the word vortex. But it's the same, right? These systems that have turning events and they actually have very strong velocity move with them. Right?
Okay, sir.
McNeil again, your turn.
And sir, would that what would cause a whirlpool to begin? Like a tornado in water. What would it?
Whirlwind.
Yes, sir.
Okay, all right. So the whirlwind is a little different now. So here what happened to the whirlwind now. You see, the wind normally flows along the Earth's surface.
No, whirlpool. The one in the water, not air.
Oh, I can't speak to that, but if I was supposed to use the same vortex technology, it would mean that you actually have a hole under the ocean. So what happened is that you see under the oceans, there are mountains and valleys just like on the land, right? But they're actually under the ocean. So if you actually have like a hole, a sinkhole type of event, it will then pull the water down. right? And you will have that turning effect. So moving from one side to the other, right? So it's the same thing. So under the ocean, just have the same mountains and valleys. So that's why if you walk out into the ocean, you just realize that you start to go down deeper and deeper and deeper, right? Until you realize that you drop off one cliff under the ocean, right? But to answer your question, I think, in my estimation, that it would have been if you have, water can create holes or sinkholes or whatever you want to call them. If that type of effect can happen under the ocean as well, and you will have that.
Thank you again. Thank you again, sir.
Okay. All right. Oh, one more question from Roger.
And the other question that I had, sir,
Yeah.
I don't know, I can't really say the name of the cloud, sir. Was it
Yes.
the
Go ahead.
cloud that produced the lightning and the thunder?
Yes,
So is it one specific cloud, sir?
that is correct. It's only one specific cloud, and it's called the cumulonimbus cloud. One specific cloud. So you don't have to remember the name. Just remember that is the only cloud that can produce thunder and lightning. No other cloud can do that. And whenever you see that cloud out there, it means a lot of things. You could have a lightning strike, which are so frequent now, or you could have a tornado, or you could have very severe rainfall from it, right? So it's three things. So you could have a lightning strike, a tornado, or very severe rainfall. So once you hear a thunder and lightning, once you hear the thunder and see the lightning, you should be in a safe place, right? Because these clouds are not something that you take lightly. Just remember that, right? Not something that you take lightly. Right?
Okay, sir.
All right, so my time for question, you guys know. You ready?
Yes, sir.
Yes, sir.
All right, because I don't see any more questions. So let me pull up my poll questions. So this is a requirement from my boss because my boss need to know if I was able to impart some knowledge to you. So during my presentation, I'll bring out a few things and I'm just gonna ask a few questions, right? So you have those fingers ready, guys? Ready for me?
Yes, sir.
Yes, sir.
All right.
Yes, sir.
All right, so let me put my first question on your screen. And you tell me, it says, how many branches are there in the meteorological service? Is it one, is it two, is it three, is it four? Answer your question, select the right answer, and click the submit button. All right, so we have 18 persons have submitted their questions already. So waiting, yeah, let's get there. Let's get those numbers up. Yeah, let's get those numbers up. Oh, we have 22. Come on, guys, punch in your numbers. Get those fingers working. My time to ask you questions. You asked me all the questions today. All right, 29. Let me see if I can go 30. 29. 29. 30 it is. All right, so let me stop the poll and let me show the results. Yep, 66% of you say it's 3 branches. Yeah, so we have the weather branch, climate branch, administrative branch. So you are absolutely correct if you said 3. All right, so let me stop that. All right, ready for another question, guys?
Yes, sir.
Yes, sir.
All right, so listen to this question now, coming on your screen. It says, when is hurricane season in the Northern Atlantic? Is it between June to November? Is it between January to June? Is it April to July? Or is it August to December? When is the hurricane season? Let's get those questions going. Let's get those answers coming. Yes, 19, we're getting there. Yes, guys, come. Punch in those answers. Let's try to get up to 30 again. So we'll go over there. All right. Let me see what I have. I have 30. Okay, let me end the poll here and share the results. 80% of you say it's June to November, and you are absolutely right. So you guys are so brilliant students today. You actually learn a lot, right? Stop that. Ready for another one?
Yes, sir.
Yes,
You,
sir.
you guys are so bright, man. You're mashing up my questions, man. All right. So let's look at one that's look at the unit. So this one says, what unit of temperature is commonly used at the Met Service? Is it Celsius? Is it hours? Is it Kelvin? Is it thermal energy? What unit of temperature? So this just means what is temperature measured in? That's all it's asking. So let's get those numbers going. Yep. You guys are doing well, man. Okay. 28. Let's see if we can get our 30 again. 29. One more. Okay, excellent. 31. Okay, 32. Okay. All right, 33. Yeah, that's good. Let's end the poll. Share the results. 73% of you say Celsius, and you're actually right. That is the correct unit that we measure temperature in. Some countries use Fahrenheit, like the United States, but the international standard here in Jamaica is Celsius. All right, I have two more questions for you guys. So I'm almost finished. So let's look at the other one. Ready?
Yes,
All right.
sir.
All right. It says, what unit is used to measure sunshine? Is it hours? Is it days? Is it inches? Is it not? We're looking at sunshine. What unit? Sunshine, remember, is a Campbell stroke sunshine recorder, right? Is the instrument. What unit? Well, we know we're at 26. Let's see if we can get up to 30 again. You guys are doing well. 30, 28. Yep. All right. Let's reveal 32. Okay. Share the results. 63% of you said hours, and you are absolutely right. You spot on, guys. Doing so well. I think this is my last question for you. Let me just put it up. So last question for the day. All right. It says, where is the forecast center located? Is it at Tinselpen? Is it at Norman Manley International Airport? Is it Maypen? Is it Manchester? Where is the forecast center? Remember, the forecast center is that one where the persons, they become weather forecasters and they can go on the television and they do weather for. So where is that located? Anyone? Eight. Come on, guys, doing well, doing well. 9:30. Okay. I take it there. So and here, share the results. 71% of you said the Norman Manley International Airport. You guys are on par, man. You get all my questions correct, right? So you did well. I feel like knowledge was has passed on to you, and I feel very happy. At this point, I just want to say thank you guys for accommodating me. It was really a pleasure, and I would probably just open the mic for the teachers, so if they wanted to have a comment before I close. But thanks again, guys. You are excellent. See you there.
Ajante, Mr. Brown, before you go, a student would like to extend thanks. Ajante?
Yes, go ahead.
On behalf of grade 5 students of Portmore Missionary Preparatory School, we would like to extend our heartfelt gratitude to you, Mr. Glenroy Brown, for taking the time out of your day to present to us. The information you share with us from your experience is greatly appreciated. The knowledge you imparted today will definitely help us as we continue to learn more about weather and climate and prepare for our exit exams. You have piqued our interest in the study of weather and climate, and again, we thank you. We truly enjoyed your informative and interesting presentation.
All right. You're welcome.
Very much, Ajante. And thanks again, Mr. Brown, for
Yep, no problem.
visiting.
All right, so I recorded the session so I could share that with you afterwards.
All right. Okay,
man.
please do.
Yes.
All right.
All right, thanks again, everyone.
Thanks a lot.
All right, enjoy the rest of your day.
So I think, hold on, sir. Can we just pray because we go for lunch now?
Okay, sure.
So can we just pray? My class, you'll meet back in my class at 11:45. How about you, Mr. Campbell?
My class, you'll meet back with Miss Myers at 11:40.
11:40 as usual, class.
Yes, ma'am.
All right, so who's
Yes.
going to pray us out?
Miss, can I pray?
Go ahead, Kayla.
Okay. God is good. God is great. Let us thank him for our food. Amen.
Amen. So have a wonderful rest of the day.
All right,
Yeah.
thanks, guys. Enjoy the rest of your day.
Thank you, Mr. Brown.
All right, no problem.
Miss Myers and Mr. Campbell, can